By popular demand, everyone kept asking me to do Norton's theorem after Thevenin's theorem, so here we are finally. Norton's theorem is very similar to Thevenin, except instead of a voltage and resistance, it is a current source and a resistance in parallel. Our goal here is going to be to simplify this circuit. A voltage source, a resistor, two resistors in parallel, and then the load. First step, replace the load, and we are going to analyze what the current is going through those two shorted points. Find what the total resistance of our circuit is from the perspective of the voltage source. The first resistor is in series, then the next two in parallel. We get 90 ohms. Next step, we need to find what the total current in our circuit is. Sub in their voltage and resistance and we get an answer, 55.6 milliamps. Now we need to use the current divider equation because after R1, our current splits into two paths. And we need to know what that path is, that second path. If you need reference, look back to my current divider equation, 17.78 milliamps. Next step is to find what Norton's resistance is. We short the voltage source and we look at the resistance from the perspective of where the load is coming from. Do the maths out step by step, 126 ohms. The last and final step is to redraw the circuit with the current source and with the resistance in parallel with the values that we just calculated. Don't forget to put your load back in. I hope these circuit analysis theorems are helping you in your studies around circuitry. Happy circuiting.